Well, hi, welcome to my shop. Thanks for joining me here today. Today is June 29th, and I'm starting on day 2 on this radio here. As I get the camera clumsily positioned. There we are. So my objective today with this radio is to change out all the electrolytic capacitors that are in it. And I've got the replacements here, which I've already tested to make sure these are good. They are all good. So I'm going to go ahead and do 1, 2, 3, 4, 5, 6, 7 capacitors in this radio, and hopefully it's going to work. It's going to work great when I'm done that. Hopefully. Okay, so you can see I have a close-up camera. We're looking through it now. See this big capacitor here and a similar one here. These are the two 100s that are in the radio. I think I'm going to switch those first. They occur here and here in the final output area of the radio. I'm going to change these two. They're large, so you could just kind of assume big capacitor doing a big job. And we'll change these two. We'll test these two and see what condition they're in, but I'll change them both and we'll see if the radio doesn't improve already just from those two alone. Okay, and so I'm going to change these through the board and bring the new leads out at the bottom here rather than try to work just on the top. There's no reason to not do it more appropriately. Best way to get these guys out actually is to heat up the board underneath and melt the solder and pull them out. Pull them out. That's got to be the best way. Okay, so I'm going to carry on with that. Okay, so the first lead we're going to try to get off is the one that's soldered right here. I'm pretty sure that's one lead of one capacitor. So I'm going to get my hand on the capacitor here. Yank it out. I've probably bent the wire over under here. Okay, so that's definitely it. Pulling it out is a little tough. So we're going to take a different approach here. We're going to try to draw off as much of the solder as I can. Here. Okay. Now for some chances it's loose. You can see it there in the camera. Pry off the trace if I pry too much on that. So I just tried to weaken the solder here. Out. Okay, it's ready to go. Now the other lead I think is right there. I got a good grip on the capacitor there. I'm going to be able to yank it out, I think. Yes, that's definitely it. I'm yanking. That doesn't want to come out. How come? the solder. It's going to fall out now. Come on, man. Just holding it in there. Jeepers. That's kind of weird. Oh my gosh, what is holding on to it? There it goes. Huh. Well, that was a lot more difficult than I would have expected. There it is though. So we're gonna put this guy right on test right away. I'm gonna do it just using this instrument here. So this is supposed to be 100. So 227 microfarads. Wow, that's a big capacitor. So when you get a reading like this, it's supposed to be 10 and instead it's 277. It's supposed to be 100 and instead it's 2.5 times that. Usually it says to me the capacitor is shot, even though it's reading like it's better than ever, like it's gained over the years. Now that's one test. I'm going to do another test here. The different instrument entirely, it uses a completely different approach. That's this guy here. So, you know, this is a low-rated capacitor, 6 volts, and my test here starts at 50. Well, could be exciting. Now I need to find the test leads. Oh my gosh, where's my test leads for this? What has happened here? Okay, I gotta stop and hunt down the leads. Hey, I just walked by the TV. Hey, what's happening in Canada with COVID? I think the last time I spoke about COVID on a video was a few weeks ago, and I was frightened, everybody was, because all indicators were going up, up, up. Well, all indicators are going down, down, down now. And the great thing about here in Canada is the vaccination rates are really high, and we're actually vaccinating more people a day now than ever. The number of people getting vaccinated is increasing on a daily basis. So a quarter million a day, something like that now. Okay, so a 6 volt. And in my own personal life, me and my whole family is double vaccinated now. So that's where we are. Then my own personal view of this about going forward is we're going to be wearing masks right around till this time next year. That's my guess, my personal guess. We will be told mask wearing is going to be required on an indoor basis, or those places that have a heightened chance of transmission, public places, crowds, stuff like that, stores, mask wearing. That's my guess. Who knows? As the Canadian modelers stated, and I heard this quite a few months ago, and I have not forgotten it, they stated, you cannot predict beyond 3 weeks. 3 weeks! You don't know what's coming 5 weeks from now. And it's kind of borne out that way, isn't it? Okay, now we get back to doing this. So one side's positive. I got these in backwards. Let's put them right. Help myself from making a mistake. This is the positive lead. Now we're going to be overdriving this capacitor a lot, so it might even pop. I don't think so though. It's good for 6 volts. I'm going to put 50 on it. Okay, and just in case it's going to pop and spew its guts, I'm going to put it over here. I don't think this machine has any potency behind it, so if it shorts out the capacitor, it will not be exciting. So what we're going to do, I'm going to put 50 volts on this crazy thing, and snap that switch before I forget. You're going to watch the magic eye. If the capacitor is good, the magic eye will end up looking like it looks right now. See how it's kind of open at the bottom? It looks like there's a shadow at the bottom here. So when I hit the switch, it'll close, and then it'll open back up to some degree. Or it'll go boom. There we go. Okay, so it's barely open. And the camera, yeah, you can see in the camera, slight opening. So a good electrolytic capacitor that can take 50 volts would be, I've got a bunch of 35 volt ones. Do we dare try it, one 35 volt one? Sure. It's a 50 volt. This is a 50 volt capacitor. It's not 35. So this is a 33 microfarad capacitor. The negative on the negative. So we're kind of testing the test here, but this isn't. Well, this capacitor is probably 15 years old. It's not that old. It's been sitting. It's NOS, new old stock. Here we go. Electrolytic. There you can see the eye opened right up. That's what a good capacitor would do. That's a good capacitor with a bit of a charge on it now. Tiny charge. Good show. So what that proves, okay, is the capacitor coming out bad, and the capacitors going in good. I'll put them in now. I'll get the other one out and put 2 new ones in. We'll see what happens. Okay, so to make it fairly easy to pull out the capacitor in question, I've shoved this screwdriver underneath one end so I can wedge it up, pull on the wire, so to speak. And it should come right out. That's if my camera will only focus. That's why I don't like using automatic focus on these cameras. They don't want to participate. Okay, can't waste my time with the camera. Out you come. There we are. Red wire came off too. Yeah, that's too bad. Too bad the camera won't focus. There's no problem. The red wire came off. Let me tack it right back on. Okay, so that's one out, except the hole is blocked now, but that's okay. Next one is right over here. So now we can lift the capacitor up, right, and get a grip on it. Pull it out, pull it out. Try and do this without burning my fingers here. There we are. Double check that it's 100. Hey, let's give it the test. Why not? Because I still have the instrument operating here. Let's give this guy a test too. Negative, positive. Electrolytic, 50 volts. Once again, same as the other one. Not opening. Now you get to, well, it's a 6-volt capacitor. You're putting 50 volts on it. What do you expect is going to happen? What I would expect if this were new, a new 6-volt, is this would pop open and the capacitor would sit there happy with 50 volts on it. I mean, those ratings are no way are they sharp ratings. Like, you know, 50 volts, if you go to 51, she's a goner. That's not the situation at all. 50 volt rating, really what they're trying to say is it's probably good for 100 volts for 40 years. That's probably what they're trying to say when they say it's okay. Now, next capacitor in. Okay, this is a 135 volt capacitor. Pulled that other one out, you know what, and it's stupid me, I did not make a note of where the positive and the negative was. Yeah, dumb. So one leg is going on this outer trace, if you like. That's got to be a ground trace out here. So if you look at the two capacitors, they both find their way to ground. In both cases, it's the, I don't know, is that the negative or the positive? So the one I just put in, you can see the trace runs from here down right to one of the connections. That's the negative connection. The positive connection is up here. That's the negative, the negative into here. The negative is a short one. So we're going to put the long one into this hole first. The long one being the positive one. Now, I'm renowned in my own world for getting this backwards. Don't know how, but gotta be at least 20% of the time I do this, I get it backwards in the end. I'm not gonna get anywhere with a soldering iron that's turned itself off. So another thing worth talking about, Canadians love to talk about, is the weather. And the weather here where I am is okay. It's rainy today, but it's nothing spectacular. It's been beautiful actually so far. There we go. I've had a beautiful spring and starting a beautiful summer here, but not so on the west coast of Canada, and of course the west coast of the United States. The same situation occurring. Huge heat wave beyond the heat wave beyond. So I certainly can't complain about the weather here anymore. So I know that people talk a lot about climate change, and they talk generally change of temperature and change of ocean levels. What they don't talk about, which is probably the thing we should be talking about, is change in rainfall patterns. You know, you don't need too much to happen to have a change in a rainfall pattern. And basically what generally happens in the world is areas are desertified. They've turned into deserts, right? And on the fringe of the desert, it's either expanding or it's contracting. I mean, I could be standing still, but not a lot stands still in the world. So under slightly increasing temperatures in the world, desertification expands. Can you think of some deserts in North America? They're all going to expand. That's really bad, because right now a lot of stuff is growing in some of those areas. Of course, my solder, like a grain in you know, Western Canada. Hey, what do I do with the solder? Here it is, right here. So to me, that's the real concern. We go into a dry spell, a drought, Well, that's what's happening. That's what's happening in California. And people aren't really ready for that. I mean, they're ready. They're thinking about the heat. Of course, the heat's there. But I think it's really drought that is going to change stuff, and maybe the opposite, where you already have fairly heavy rainfall, and they get much, much, much heavier, and start having flooding problems and all that kind of stuff. So anyway, that's the story. If you're not in North America, you may not be aware, but there's a cookout happening on the west coast of North America. Very serious thing. Okay, so I got the two capacitors in. Let me just trim the wires off here. I'm going to turn this guy on. Swing. So that wire bounced off the wall and came all the way back here somewhere. The first one. Good shot. Okay, speaker's still connected. Got to hook up a little bit of power. And then we'll try this radio. See what it does now. Okay, power supply's hooked up. Let's give it a shot here. Well, it's working. So, big problem receiving stuff in my shop. But let's try and see what we can do. So I really want to hear a voice come out of this. So I can hear what the sound is like. Let's turn it this way. Ah. Okay. I've got to do something here. Well, the good news is the radio's working. It's just not receiving well. Again, in my shop, maybe that's the reason, or it may need some alignment work done to it also. Boy, I really want to make some sound come out of this so we can hear the quality of it. So I got to figure out a way. I got to make a little broadcast station here or something. So I've got signal generators set up here to help with this, but let's play around with this antenna just a little bit more. This is the antenna lead coming from an outdoor antenna. Yes, I've got it shorted there. Now, this is tricky business because you really got to pick up a little wee bit of the signal. First thing I can do is I can clip this right onto the antenna lead here. Just a pile of noise. Attach the ground. Something a little odd going on right in here. What's that? Okay, so we're not going to get anywhere with the antenna. We'll give up on that. It's just bringing more and more noise. It's just a wire antenna. So this is the output of the signal generator over here, which is set to about 1 million hertz. Lots of wires running around. First, what we're going to do is just going to try to couple it to the antenna here just by looping it in some dumb way. And we'll see what happens. Just stay there like that. Now, 1 million's about the middle here. Lots of weird stuff still happening. Here we are. Oh my gosh. Why all that? Disturbed that antenna so much. What is going on there? It's not supposed to sound like that. Okay, so I'm going to set the tuning here just to a spot. And I'm going to tune the signal generator. It's actually easier this way. We'll know for sure when the signal generator is being picked up. There it is there. Okay, let me just, this is right at the end of my, the range of my signal generator here. So let's go up a little bit. Strange stuff. We should hear a 1000 hertz tone coming out here. That's really quite bad. Let's go a little higher. It's too much for the little radio. Let's put that a little farther away. That's a little better. That's 980. Now it could be interference because just where this is tuned, I'm going to tune it slightly off again. So I just hear the static. Pretty much on 1,000,000 now. Something very weird going on with this radio for sure. Changing the frequency from 1000 to 400, the tone we should hear. Doesn't hear much. Well, okay, so the result of all this experimenting is the radio's really buggered up. That's kind of the only real conclusion I can come from that. Changing those two capacitors hasn't helped, hasn't hurt it, doesn't seem to have helped, but we can't really tell doing this kind of stuff. Primary thing is radio's still working despite the fact I'm doing stuff to it. Okay, so we're ready to do a few more. So I think next are some 30s, two 30s, and then 310 microfarads, two 30 microfarad capacitors. I'll do the two 30s next. Where are those guys? Well, I made a stupid mistake here. You know, it's really good. I got the polarity right on this capacitor. It's the wrong capacitor. I put in the wrong capacitor. Day. If there's a wrong way to do it, I will find it. I'm your man. Okay, let's see if having the right sized parts in it make a difference. Now the two capacitors are in the audio section, so I don't imagine it's really made much difference at all that we can hear. Let's see. You know, it has made a difference. Yeah, that just proves. I don't hear the modulation though. Nope, can't hear the modulation at all. Good enough though, good enough for now. Yeah, better to put the right size in. That was not a small mistake. I was out by a factor of 10. That's a big amount. So, okay, now we will go on. Ooh, that wasn't a good thing. Let's go on to the next two guys here, which are two 30s. Now, can we recognize them in the radio? Just because of their size. There's a whole pack of them back here. Let's take a closer look. See what we can figure out. Still have the automatic focus on here. Let me get rid of that annoyance. So, I think all these are capacitors. I see 4 in there. I can see one I can read on it. It could easily say 30 or something like that. That's this one back here. Three volts, 30 microfarads. 3 volts, 30 microfarads. So that's one. Now, just over here are two smaller cans, and here's one that's the same size as that one. These are probably the two here. And then there has to be 3 more, and I see one way down here. 1, and 2, and 3. So I think that's the count of them. Occasionally these things, capacitors, and well, I like this, and some transistors, they look pretty similar, but I'm pretty sure I got it right. So we'll do these next two capacitors here and here, and in the hopes one of these is going to do it. Still, it's all in the audio, and it seemed to me some of the rough sound was really in the radio section, but we'll just keep working our way through. Okay, so now we've done these 4 capacitors. Let's see what we get this time. Well, sounds like a radio, but there's a voice there. So what I'm hearing is the same kind of distortion that was there at the start. Okay. Carry on with the theme of capacitors. I only have 3 more to do. 3 more electrolytic capacitors. If that doesn't solve the problem, then I think probably the diode is the next thing I'm going to go after. But let's stick on the capacitors here. 3 more to go. So I just show you what I'm doing here to save myself from myself. Before I take the component out, I put a red mark on it, with just a red marker. I don't really know what I'm marking. I'm just marking this is the position, this is the side that was up. Then once I take it out, I can then look at it and find out, okay, there's the positive indicator, that's the positive terminal, and the red side is the negative. So now I know the negative is the upper one. That's how I'm keeping track of this. And I'm going to try to put in the right size capacitor this time too. Okay, well, it's time for another test. I've done the remaining electrolytic capacitors. There's none in here now. It's off. There's all the dead bodies there. Okay. What do we get? Sounds different. Where'd that station go? Wow. Not receiving. I think that's it there. Maybe not. We gotta get a station in here. Let me try this right on the antenna. That's 590. 640 should be. So 590 down here. This sports station is well, it's definitely better. That definitely improved it, but it still doesn't sound quite right. So still more things we can poke around here. I'm just kind of crossing my fingers that it's not a transistor, but it could easily be a transistor that's gone bad. One thing at a time though, so that's pretty good for now. So thanks a lot for watching, and tomorrow we will pursue this further.